I'm going to describe an interactive simulation for adiabatic reversible expansion or compression. This is in a piston and cylinder, so the equations apply for a flow system also. The simulation is located at the link indicated here, and this is a snapshot of simulation. We have the option of either looking at compression or expansion. We can pick the final pressure, and we're going to calculate the work, the final temperature, and then the final volume relative to this initial volume. Since it's reversible, the external pressure is going to be the same as the internal pressure at all times. So let's look at the interactive simulation. First, point out the details here show the equations used to determine the values of temperature, volume, and work. And if we look at compression, let's say the final pressure 1.89 megapascals, we click to start. And what we're showing is, because it's reversible, the external pressure is always the internal pressure. And so these weights represent that and let's reset so we can see. Initially, there's no weight. This 1/10 of megapascal corresponds to the atmospheric pressure. The piston has no weight, the atmospheric pressure of about 1 bar of pressure. And then as we compress, we keep adding weights until we get up to 1.89 megapascals pressure. And you'll notice, calculate final temperature, much higher, volume, of course, much smaller, and here's the work to carry that out. For expansion, we now start with weights, and we're going to go to, let's say, final pressure of 1/10 of megapascal. So again, when we start, we remove weights continuously to keep the external pressure, internal pressure the same. Got this much work done, and of course the temperature drops. So the idea is to give you a little better physical feeling for adiabatic reversible expansion or compression of an ideal gas.